Okay, we're now recording. Okay, so a lot of what I'm going to say for the next few minutes is repetition. And you say, why do I repeat myself so much? Well, that really gives somebody no excuse, I would suppose, and say, oh, I didn't know the day of the test, or I didn't know how you do the homework. I've been saying it over and over and over, right? And the rest of you guys can hopefully vouch for me because I say it so much. All right, so today is just a review day. I do not plan on doing any new material. Okay, so when the questions run out, we will just end. I don't plan to do new stuff because the new stuff is derivative shortcuts, and I'd rather not give you derivative shortcuts, you know, unless you want to use them on tomorrow's test. So again, those of you who know derivative shortcuts, you cannot use any of those for the test tomorrow. Okay, so test tomorrow. That's all we're doing. So if you have any questions, it has to be today, or come office hours or go to the Math Resource Center, as the case may be. Okay, so what do I turn in for homework, you say? You turn in all of this, and I'll take it as soon as class is over today. Okay, so I don't want homework too early, but let's say as soon as the day before the test ends, you can always submit the homework. So you may submit the homework starting at what, 10 o'clock up until tomorrow at 10:30. Okay, so you submit all this homework. Again, it may not all fit in one file, so you may have to break it up into several emails or whatever. That's perfectly fine. So 70% homework requirement. So if you don't turn in at least 70% of the homework, I don't grade your test. It'll count as a 0. Okay, show all your work. When in doubt, show as much work as we showed you in class. So don't just give me an answer. I need to see, how you got your answer. Okay, you're allowed one cheat sheet. So one 8.5 by 11 sheet of paper. Put anything you want, front and back, sample problems, formulas. That's all legal. And you can use a calculator, of course. And then after that, that's it. So no other books, no notes, no computers, internet, cell phones, people, right? You can't have anything else to help you. Okay, so tomorrow, a little bit after 9, so maybe 9:01, 9:02, I'll send the exam through Canvas announcements. Don't look at Canvas quizzes. I don't have anything on Canvas quizzes, just Canvas announcements. The same place where I give the daily videos. Okay, I'll give the homework, then you join, and you have to have your camera on for the entire test with the true background. So background should not be Golden Gate Bridge or something like that. Your true background behind you, and keep yourself muted. If you have a question during the test, send it in the chat. Don't blurt it out to everybody else. And if you happen to finish early, you can leave early. And again, just take pictures on your cell phone and submit to me. Okay, so I will close the class as usual at our normal stopping time of 10 o'clock. You then have 5 minutes to submit your exam by 10:05, and then you have until 10:30 to submit the homework. Okay. Questions are just like the homework. I don't give any tricks. I don't give any surprises. So if you can do everything here, you should be okay on the test. Now, I tend to give about 10 questions, so that means you can probably expect one from each section and maybe another couple somewhere else. Okay, I'm not promising 10, but about 10. So 10 is a good chance, maybe 9 or 11, less likely 8 or 12, but usually quote unquote around 10. Okay, and I think that's all I have to say about the test. If you have any questions about the test itself, you can also put that in the chat. All right. Okay, so I will now go ahead and get that. Okay, and thank you, Prasanna. So Prasanna put something that he has a review session today at 3. If anybody wants to go with Prasanna for that, that would be great. Okay, so let me make a list as to what I've got here. 2.3, and I only want to do problems that were assigned, so don't have me do some problem out in left view that wasn't assigned. Okay, so 25 and 29, 2.4, 18, 20, 24, 2.53, 2.37, 2.3, 29 and 41, 2.6, 25, 27, 29, 2.8, 27, 2.5, 53, 55, 2.617. Okay, 2.4, 1, 15, 27, 2.2, 25, 2.3, 29, 2.5, 49B, 2.6, 27, already got that, 29, already got that, 41, 45, 2.7, 15, 2.5, 41. Okay, that's a lot of problems for now. I'm not even sure I'll be able to get to all of these. So we'll just do the best we can. And because there's so many problems here, as I often say on this kind of day, I'm aiming for quantity more than quality. I want to make sure that I get everything down. You can always look at the video later to check up on this stuff, okay? So I'll be trying to get through all of them, but in order for me to do that, I'll have to go very rapidly, okay? So let's see, 2.225, and you may keep typing stuff in if you wish. And Prasanna, if you can answer something quickly, you're allowed to do that also. Okay, 2.2. 2.225. Limit theta approaches 0. Sine of 3 theta over tangent 2 theta. Okay. Now let's see. Sine is odd. Tangent is odd. Therefore, the ratio is even. Okay, so that means I can get by with plus or minus. So to save time, I'll just do plus or minus 0.1, plus or minus 0.01, and put it in a calculator. Okay, and this should be in radian mode. So let's see if I'm in radian mode. Okay, so here we go. Sine 0.1, sine of 0.3 divided by 10.2. 1.4578. And then 0.03 divided by tangent 0.02. 1.499. Okay, so our guess would be maybe 1.5. Okay, and that's as much as I want to do on that one. 2.3. 2.3, number 7. It should not really be that hard. All I'll say is that for 2.37, you're allowed to just plug it in. Okay, so put an 8 there. Cube root of 8 is 2. Put an 8 there and 8 there and grind it out. Okay, it's very straightforward. Okay. The only ones that cause trouble are if you have to divide by 0. So you should be happy if you get, problems like this on the exam. Just plug it in. Okay, so that's as much as I'll say that one. It's just a plug-in. Okay, and let's see, still on 2.3, 25. Okay, 2.3, 25. Limit as t approaches 0. Radical 1 plus t minus radical 1 minus t all over t. Okay, so multiply by the conjugate of the numerator. Radical 1 plus t plus radical 1 plus t. Radical 1 plus t plus radical 1 plus t. Limit t approaches 0. Okay, usually you don't want to multiply out the bottom. Let's see, what did I do? That should be a minus there, sorry. And unfortunately, there's no way to undo a plus with a minus. Minus there and there, okay? Unless I had whiteout, but I don't have whiteout. Okay, so square that, it's 1 plus t minus parentheses 1 minus t over t, paren, radical 1 plus t plus radical 1 minus t. Okay. This comes out to be 2t. 1 minus 1 cancels out. You have t minus a minus t, and that t is going to cancel that t. So limit t approaches 0 of 2 over radical 1 plus t plus radical 1 minus t. Now I plug in 0 here and a 0 there, and that's easy. So 2 over radical 1 plus nothing plus another radical 1 plus nothing. So that's 2 over 2 or 1. Okay. And 29. Limit t approaches 0. 1 over t radical 1 plus t minus 1 over t. Okay, multiplied by radical 1 plus t, top and bottom. One minus radical 1 plus t over t radical 1 plus t, okay? And in order for me to do more variety of problems, I'll just stop here. Say you do the same thing of multiplying by the conjugate, okay? So it's a similar style, but I want to go over different types of problems. Okay, so the concept is the same as the previous one. Okay, so that's as much as I feel like doing for that one. And 41 should be just a plug-in. 41, just plug in 3. Okay. All right, so that's 2.3, 2.4. Number 1. Okay, so you have to pick the delta, which works. Remember, delta is going both to the left and to the right. So this side is 0.3, this side is 0.1. So you pick the smaller number, 0.1. Okay, so when you give a picture like this, the smaller number is the one that you want, 0.1. Okay. Okay, then 15. I mean, we could do a lot of these proofs, but I may have to skip some. 2.415. Limit x approaches 3 of 1 plus 1/3 x equals 2. Okay, so you always start with the same language. Given epsilon greater than 0, find delta greater than 0 such that 0 less than absolute x minus a is 3, less than delta implies absolute value of f of x, minus the limit, which is 2, is less than epsilon. Okay, so 1 plus 1/3 x minus 2 less than epsilon implies 1/3 x minus 1 less than epsilon. And if I multiply both sides by 3, that gives me x minus 3. So that implies absolute x minus 3 is less than 3 epsilon, and that looks like that now. So let delta equal 3 epsilon. Okay, I'll come over here for the formal proof. 0 less than absolute x minus 3 less than delta implies absolute x minus 3 is less than 3 epsilon. Multiply both sides by 1/3. So 1/3 absolute x minus 3 less than epsilon. Distribute that back in. 1/3 x minus 1 less than epsilon. And then just write it the way that I need to, which is like this. So that implies 1 plus 1/3 x paren minus 2 is less than epsilon. End of proof. And double check that that works. Yes, that's correct. Okay. Okay, that was 15. I know some of you put others in 2.4, but I want to make sure I do a variety of every type of problem. Okay, so I'll only come back to 2.4 if I have time. Okay, so I can go back to others. 2.5 stuff. 2.5, number 3. Number 3. Where's the function discontinuous? Well, wherever you have to lift up your pencil from the paper, you don't really have to state why. So -4, -2, 2, and 4. -4, -2, 2, 4. Okay, -4 is neither continuous from the left or the right. -2 is continuous from the left. +2 is continuous from the right. And 4 is continuous from the right. Okay, so for part B, -4 is neither. -2 from the left, +2 from the right, and +4 from the right. Okay. Okay, let's see, 41. Where's the graph discontinuous? So we have x squared, x less than -1, x, if x is between and including -1 and 1, and then 1 over x, x greater than or equal to 1. This should actually be strictly like so. Okay, so very quick graph. Okay, x squared, x is less than -1. Open circle, I know it's a parabola, goes like that. X from -1 to 1, that's from there to there. And let's see, including this point, not including this point, and then over here, 1 over x. When I plug in 1, I get 1, so that closes up the hole. So there's the graph. Okay, so discontinuous only at x equals -1. But -1, it is continuous from the right. Continuous from the right. Okay. And let's see, 49b. F of x is equal to x cubed minus x squared minus 2x over x minus 2 at a equals 2. Is there a way to remove the discontinuity? Okay, so let's factor the top. X times x squared minus x minus 2 over x minus 2 equals x times x minus 2 x plus 1 over x minus 2. Cancel, cancel, equals x times x plus 1, as long as x is not equal to 2. So how do I make it continuous? I plug up the hole by defining let f of 2 be 2 times 3 or 6. So that's it. Okay, so this graph has a hole at 2, 6. So just plug up the hole by defining f of 2 to be equal to 6. Okay, so that's 49b. Okay, 53 and 55. I'll do 55. The harder of the two. Intermediate value theorem. E to the x equals 3 minus 2x between 0 and 1. Okay, so get everything on one side. So if I throw these two over, it's e to the x minus 2x plus 3. Okay, f of 0 is e to the 0 is 1 minus 2 plus 3, which is 2. That's greater than 0. And let's see. F of 1 is e minus 2 plus 3. And that doesn't seem to work. Oh, I get it backwards. It should be plus 2x minus 3. Sorry. So that should be plus 2 minus 3. Minus. Try that again. E to the x plus 2 minus 3. So I plug in 0. Ah, this should be 0. Negative 2. Okay, now I'm on the right track. F of 1 is e plus 2 minus 3, which is greater than 0. Right. Okay, so one side's less than 0, the other side's greater than 0. So by the intermediate value theorem, there is a c somewhere between 0 and 1, such that f of c equals 0. Okay, and of course f is continuous. Okay, exponentials are continuous, polynomials are continuous, sum of continuous functions are continuous. Okay, so crude picture, you have a 0, negative 2, 1 comma some positive. So somewhere there's the c, somewhere we have to cross the x-axis. Okay, so that's that. Going on to another section, 2.6. See what I want to do over there. 2.6, 25. I think I did that one just at the end of class yesterday. So look at the video for that. 27. Okay. So limit x approaches infinity of radical 9x squared plus x minus 3x. Multiplied by the conjugate, 9x squared plus x plus 3x. Radical 9x squared plus x plus 3x. So the numerator becomes a squared minus b squared, 9x squared plus x minus 9x squared. That's very nice. These guys cancel out. Over radical 9x squared plus x plus 3x. Limit x approaches infinity. Limit x approaches infinity. So the numerator is just x. Denominator is this. 9x squared plus x plus 3x. Okay, now divide top and bottom by x. So divide this by x, divide each of these by x. That's a trick, right? Divide by x. So I end up with, running out of space here, limit x approaches infinity of 1 over radical 9 plus 1 over x plus 3. Okay, so now when x gets big, that's 1 over radical 9 plus 3, 1 over 6. Okay, multiply by the conjugate here, multiply by the conjugate here. Okay. 29 is similar, so I'm not sure I want to do that one. 17, okay. 2.6, 17. X minus 2 over x squared plus 1. Okay. Divide the top and bottom by x squared. If they're different, you can divide by whatever's on the denominator, x squared. X minus 2 over x squared plus 1, and divide top and bottom by x squared. Limit x approaching negative infinity. Okay, that's 1 over x minus 2 over x squared. 1 plus 1 over x squared. Okay, so when x goes to negative infinity, that's 0, that's 0, that's 0. 0 minus 0 over 1 plus 0, which is 0 divided by 1, or 0. Okay, let's see. 41. Okay, to save time, I'm not going to write the problem. The trick for this one is to write it as a quotient. Okay, limit of ln that over that. That's a property of logs. Okay, so I'm going to write it directly as that. Ln of 1 plus x squared over 1 plus x. Okay, these two are allowed to switch. That's one of the properties of limits. So ln limit x approach infinity of 1 plus x squared over 1 plus x. See if I did that right. Okay, I'll divide by the degree of the denominator. So divide top and bottom by x. Ln limit x approach infinity. So that's 1 over x plus x over 1 over x plus 1. Okay, that goes to 0, that goes to 0. Okay, so that's 0, that's 0. Okay, and that gets big. Ln of big is big. So the answer is infinity in this particular case. Okay, and let's see. 2.6, somebody asked for 45. I don't think that was assigned. So we'll skip that. 2.715. Time is it? I think 40. 2.715. I'm pretty sure we did that the other day. So all I can say is check the video for 2.715. 2.827. Find a derivative of radical 9 minus x. Okay, g prime of x, limit h approaches 0 of radical 9 minus x plus h minus radical 9 minus x all over h. Radical 9 minus x plus h plus radical 9 minus x. Radical 9 minus parentheses x plus h plus radical 9 minus x. Okay, so limit h approaches 0. Square this and you have 9 minus x plus h minus 9 minus x over h times radical 9 minus x plus h plus radical 9 minus x. 9's cancel out, x's cancel out. 9 minus 9, negative x minus a negative h. So you have a negative h on top. The negative h will cancel the h on the bottom, leaving you with just a negative 1. So you have negative 1 over that and that. Okay, I got to go back up for that now. So limit h approaches 0, negative 1 over radical 9 minus x plus h plus radical 9 minus x. Okay, so now you plug in 0 here, right? Put a 0 there. You have radical 9 minus x. Here's another radical 9 minus x, so you have 2 of them. So negative 1 over 2 radical 9 minus x. Okay, so that's 2.827. And let's see. Okay, I've finished that round. I see more stuff in the chat. But I've shown you at least one of each type of problem. So there were more questions about epsilon delta. So let me see if I can go back and do epsilon deltas. See, what do we have? 15 more minutes roughly, or 15, 20 more minutes. Okay, back to 2.4. See if I can do something that I did not do before. Okay, 2.418. 18, 20, 24. I talked about 24 before. 27 I did before. Maybe the hardest from the bunch is 20. Okay. 2.420. Prove limit as x approaches 10 of 3 minus 4/5 x equals -5. Okay, I'm not going to write the language now. So, you write the language, but to save time, I'm not going to write the language here. Okay, so given, etc. I'm not going to let you write given tomorrow. You have to write the whole thing, but now I want to save time. 0 less than absolute x minus a less than delta implies absolute value of function minus the limit, minus or minus 5, is less than epsilon. Okay, so 3 minus 4/5 x minus a minus 5 less than epsilon. 3 plus 5 is 8. 8 minus 4/5 x less than epsilon. Okay, so what I need to do is get that to be x. I can do that if I multiply both sides by 5/4. So 5/4 absolute, and I'm going to turn this around, which you can do within the bars. 4/5 x minus 8 less than 5/4 epsilon. So how did you know to do that? I want to get that to be x, right? I don't want 4/5 x, so I multiply by the reciprocal. Okay, distribute that in. Then you have absolute x minus 10 less than 5/4 epsilon. X minus 10 there, x minus 10 there. So let delta equal 5/4 epsilon. Okay, so start to prove. 0 less than absolute value of x minus 10 less than delta implies absolute. And now I know ahead of time that I need to turn it around, so I might as well turn it around. Absolute value of x minus 10 is the same as absolute value of 10 minus x is less than delta, which is 5/4 epsilon. And then multiply both sides by 4/5. So 4/5, 10 minus x is less than epsilon. And put the 4/5 in. 4/5 times 10 is 8 minus 4/5 x less than epsilon. And now just write it the way that we need to. Absolute value of 3 minus 4/5 x minus a -5 is less than epsilon. And a quick double check, is that correct? Even though normally you wouldn't make such a step, but it's valid. 3 minus a minus 5 is 8 minus 4/5. Yes, it's all there. Okay, I know there were some more problems that were asked, but I'm going to stop and double check the chat and see what's worth doing and what's not worth doing. Okay, and I'm not sure if I can keep track of everything. So, and I don't remember where I left off. So 2.541, okay. 2.85. Okay, and thank you, Prasanna, forget that. Not sure if that does it. Let's see, I lost my place. $2.831. Okay. did we have to do 2.641? Check my list. 2.641 does not look like it's on our list. So yeah. So if I ended up doing it, 2.827, how did I get the denominator? 2.827. Okay. $2.827. How did I get 2? Okay, I think you're talking about right over here, probably. Okay, so put a 0 right there. Put a 0 there. You have radical 9 minus x plus another radical 9 minus x. That's 2 radical 9 minus x. Algebraic, it's the same as a plus a is 2a. Right? If I have one of an object plus another of the object, I got 2 of them. So if you put a 0 here, right, it's radical 9 minus x, and then you're adding another radical 9 minus x, so you have 2 of them. Okay, so I think that answers the question. So how do you know what degree to divide x by? For most of these problems that involve fractions, divide by the degree of the denominator. It should always work. Okay, technically you could divide by the numerator also, but any of these problems, divide by the degree of the denominator, and that should work in general. Okay. Let me check something else about 2.541, and Prasanna brought it up too. So thank you, Prasanna, but let me check to see what's going on there. 2.541, is it worth doing? Yeah, we did that one somewhere already. 2.541. So the function is definitely not continuous at x equals -1. It is continuous from the right, because as I approach from the right side, the limit is -1. The function value is also -1. That's what makes it continuous from the right. Okay. Meaning, if I come from the right side, I can actually hit the function value without lifting up my pencil from the paper. Okay, that's not so in this particular case. Okay. All right, let's see, get some other things here. Let's see how much time I have to get through all this. Okay, so 2.541, we just talked about that. Okay, some other derivatives, 2.8, number 5. Let me see if I have time for that. We only have, what, about 10 minutes or less? Okay, 2.8, number 5. Ah, yes, that kind of problem. Okay. 2.5, 2.8, number 5. I got it backwards. 2.8, number 5. Okay. Slope is 0. Large positive. Looking at slopes now. Large positive, small positive, 0. Then large negative, small negative. Thinking of the slope, you're on the roller coaster. Steep, steep, less steep, 0, very steep, not as steep. Okay, so large positive, at the origin it comes down to 0. Large positive, small positive, 0. Okay, then it jumps down to a large negative and it comes back and becomes a small negative. Oops. It's supposed to be smooth there. Okay, so something like that. Okay, 31 to x to the 4th power. Okay, so we did that before. Okay, so limit h approaches 0, f prime of x plus h to the 4th minus x to the 4th all over h. Okay, so multiply that all out, or you can use Pascal's triangle, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So limit h approaches 0. So the coefficients are 1, 4, 6, 4, 1, x to the fourth, 4, then x goes down by 1 and h goes up by 1, x cubed h. Then 6, x goes down to x squared, h goes up to h squared. And then 1, 4, 6, 4, 1, 4 x to the 1 h cubed plus 1 h to the fourth, and then minus x to the fourth all over h. So again, it goes 1, 4, 6, 4, 1, x to the 4, 3, 2, 1, 0, h to the 0, 1, 2, 3, 4. Okay, that cancels out with that. There's an h left over. So h paren 4x cubed plus 6x squared h plus 4x h squared plus h cubed all over h. Cancel, cancel. 4x cubed plus 6x squared h plus 4x h squared plus h cubed. And now plug in 0. That's gone, that's gone, that's gone. So 4x cubed. Okay. And let's see. Oh, I can't catch the, I'm not able to get the chat anymore unless I do something funny. Nope, I can't see the chat unless I stop the screen share. Okay, what do we have? Only a few minutes left. Okay, that being the case, let me try to go back to 2.629. Okay. Okay, radical x squared plus ax minus radical x squared plus bx. So that's where you play the same game as that other problem. I kind of painted myself into a corner. Radical x squared plus ax plus radical x squared plus bx divided by, sorry, I'm saving time and I'm not letting you do this on the test, but I'm doing it to save time. Ditto marks, same thing top and bottom. Okay, sorry. I'm trying to save time here, but you don't write the ditto marks. I know I'm setting a bad example. Okay, so a squared, x squared plus ax minus b squared, x squared plus bx all over the denominator, which is radical x squared plus ax plus radical x squared plus bx. Okay, so this, copy and paste that over there, if that helps any. Okay, so that's going to cancel out. I now have limit x approaches infinity. X squared cancels. I have ax minus bx, raise it up over radical x squared plus ax plus radical x squared plus bx. Okay, divide top and bottom by x, which means x squared underneath the radical. You've seen that game before. Okay, so limit x approaches infinity. That's just going to be a minus b over radical 1 plus a over x plus radical 1 plus b over x. Okay, and now as x goes to infinity, that's gone, that's gone. So I have radical 1 plus radical 1. So final answer is a minus b divided by 2. Okay, and I think that's it. In order for me to check the chat, I got to stop the share. So let me stop the share, but maybe that's all the time we have anyway. See, it's 9:57. Okay, so let me check the chat. I think I've caught up with everything I needed to do. 2.427. See, what was that one again? Okay, 2.427. Yeah, that was the double absolute value one. Do I have time for that? Okay, 2.427. Limit x approaches 0 of absolute value of x equals 0. Okay, I think I just might have time to do that. And then we'll call it a day. All right, so this one. So given epsilon greater than 0, blah, blah, same language. Absolute value of x minus a, 0 less than absolute value of x minus a, less than delta implies absolute value of the function minus the limit is less than epsilon. Okay, absolute value of x minus 0 less than epsilon. Well, the absolute value of x is the same as absolute value of x. Okay, and now that looks like the left-hand side where this should be x minus 0. So let delta equal epsilon. So the proof 0 less than absolute x minus 0 less than delta implies absolute value of x minus 0 is less than epsilon. That's the end of the proof. Because once you have one level of the absolute value, any extra absolute values after that isn't going to change anything. That's going to be pretty much the same thing. All right. And we are out of time, folks. Right. So that's about it. I'll see everybody for the test tomorrow. Okay. All right. Bye, everybody. Have a good day.
Thank you.